Hello, I'm Wendy Zika, Director of AI and Machine Learning Visuals at SAS. Today I'm going to be showing you Model Studio in SAS Viya for creating pipelines that represent the steps for building a machine learning, text analytics, or forecast model. And I'll be focusing on the automation that's available to help you model at scale and enhance your productivity, as well as the tools for responsible AI that provide the checks and balances for the automation and ensure that you have a model you can trust and that is fair. So here we are in the web-based platform SAS Viya, and you can see the various phases of the analytics lifecycle here from the applications menu, from preparing and wrangling your data to managing the models you've created so they can be deployed and monitored. But again, we're going to focus on this building model phase. So let's take a look. Here on the projects page, you can see all the projects that have been created in Model Studio in the three domains: machine learning, text analytics, and forecasting. We are mostly going to be focusing on machine learning today, but we'll take a brief look at the other domains as well. So let's get started by creating a new machine learning project. I just need to give it a name and select our data. In here, we're going to be looking at some home loan data. Now, when the project is created, we have something called the Data Advisor that automatically profiles the variables in your data and determines certain attributes about them. Most variables will be assigned a role of input initially, but the advisor will look at things like, does a variable have too many missing values? If so, it will automatically reject it from the analysis. Or a numeric variable with only a few levels will be characterized as a nominal or class variable instead of interval or continuous. This eliminates the need for you have to manually examine possibly thousands of variables, though you do have all kinds of statistics here at your fingertips to help guide you in case you do want to manually override any of these settings. Now, as I mentioned, this is home loan data with each row in the table representing an individual, and we can look at the data here and see we have columns representing various demographics, information about the loan, and whether the individual repaid the loan or not. And that's what we're trying to predict. So we're going to set that as our target. And I mentioned responsible AI earlier. One thing you might need to keep in mind when you're building a predictive model is whether that model is fair across various groups. And these groups could have been identified by a data steward in a previous phase of the analytics lifecycle as sensitive variables. So here we're going to tag the variables representing education level, gender, and marital status as ones that we want to assess for bias. So we can be aware if our models are either performing or predicting differently across any of these groups. Now we're ready to move to our Pipelines tab. And here on the left, you see what we call nodes that represent the various tasks as part of building your model. So we have tools for pre-processing your data by imputing or transforming variables, filtering out outliers, or reducing the dimensionality in your data. All the common machine learning supervised learning algorithms, and more, including a SAS code and open source code node that allow you to insert your own SAS, Python, or R code into the pipeline, giving you the ultimate flexibility in creating new variables or models. Now you can see when you drag any of these nodes onto the pipeline, there are many properties representing various options or hyperparameters for that node that you have full control over. So how can you get started with creating a pipeline with so many nodes to choose from and properties to set? You've probably heard about automated machine learning or AutoML, and that is something available to you here to help you automatically generate a pipeline, whether you're a novice data scientist or even an experienced one who just wants a pipeline to get started with and not have to figure out the best feature engineering to do and which models and combinations of hyperparameters are optimal, and just have the software figure that out. AutoML can be a huge productivity enhancer for anyone. The great thing about Model Studio is that you don't have to just do all AutoML or none. There is a whole spectrum available to you that I'll be talking about. So first, let's start with full AutoML. You want the whole pipeline generated automatically for you that is optimal for your data. And to do that, we can create a pipeline with this option set, and we can just use the defaults or can include, exclude, or force various model types into our pipeline. This will return the pipeline with the top 5 models in the time allotted. It will try various pre-processing steps, the models indicated, optionally the best ensemble of those models, and tune hyperparameters. We've recently introduced meta-learning into this process. This has the results from tuning models on a whole suite of data sets readily available to provide the best hyperparameters based on data sets most similar to your data in terms of various meta features. And that gives a great start at values to either use directly or as a starting point for further hyperparameter tuning if there is time for that. Another option for creating pipelines is to use templates. And here you can see there's a whole library of templates supplied for you by SAS to help you get started, from basic templates including regression models to advanced templates with more sophisticated machine learning models. And these templates could also be created by you, so you can save and reuse that perfect pipeline that you've created, or ones that your colleagues have created and shared with you. And you can see some of those shown in this list too. Besides saving an entire pipeline, you can save and share individual nodes. These could be SAS or open source code nodes whose code you want to save to be used in other pipelines or projects, or nodes whose properties you've changed to suit your needs that you want to reuse. So I'm going to select this advanced template for a class target, and let's take a look. Now you can run this template as is, or you can make changes to it. Now let's look at the properties for this gradient boosting node. As I mentioned, you can set these various hyperparameters and options to the values you want, or use the smart defaults provided here. Or to reduce the manual effort involved with trying and adjusting values for these hyperparameters to find the best ones for your data, many of our supervised learning nodes have auto-tuning available. This will automatically determine the best combination of values for these hyperparameters for you. This process uses an intelligent iterative search over the hyperparameter space using optimization techniques to minimize an objective function like misclassification error. It's training and evaluating hundreds or even thousands of models using distributed and parallel processing to do this as efficiently as possible. So here are all the different values that can be tuned, and you can set the ranges to tune over and starting values. And here you can see various search options that are available. We've recently made several enhancements to auto-tuning, where you can save out the history table of all the hyperparameter values that were tried and evaluated. Then if you ever wanted to do further auto-tuning, you could use those as a warm start and not have to start from scratch and rerun those evaluations. There's also an option to set the properties for this node according to the best tuned model, so that if you were to have new data to retrain in this project, the auto-tuning wouldn't have to rerun and you wouldn't have to manually set the previously found auto-tuned values as the node properties. Yet another time saver. And of course, another way to build your pipeline is to build it from scratch. Here you can just drag or drop to add any child nodes into the pipeline so you can try any combination of data pre-processing and supervised learning models that you want. Now back to AutoML and the various degrees of it. Maybe you know what model or models you want to use, but aren't sure about the feature engineering that is needed for your data. You can use the feature machine node to automatically figure out the best way to transform each variable based on the various data issues that you want it to address, like missingness, skewness, or high cardinality. And it will automatically generate new features for you. On the other hand, maybe you know the feature engineering you want to do, but aren't sure about the models and all the hyperparameters to set. You can use this model composer node that will auto-tune several different model types with multiple rounds of auto-tuning. You get a whole modeling tournament in one node, again with potentially thousands of models being run, assessed, and compared while leveraging parallel and distributed computing. One thing to notice is that anytime a supervised learning node is added to the pipeline, a model comparison node is automatically connected at the end so you can easily compare any models you include, and it will select the champion model for the baseline based on the criterion you specify. And I mentioned the open source code node. Here we actually have a node that was saved that contains the Python code to build a random forest model. So I'll bring that into our pipeline as well. And I'll open it up to show you quickly. We do indeed have Python code in here below this header, just like you would have in any Python IDE. And note that it's colored purple like our model composer node. It can be used as a supervised learning node since it creates predictions. And this means you get all the assessment and fit statistics just like you would for any of the other supervised learning nodes. Now let's look at a project where all three of these pipelines have been run. First, let's look at the full AutoML pipeline that was automatically generated for us. You can see that the pipeline includes a regression model since we had specified to force that in, so we would have at least one interpretable model. And of all the other models it tried, 4 gradient boosting models performed the best, with each one either having different pre-processing leading up to it or different hyperparameters. Now let's look at the node we created with our template. And we'll open up the results of our gradient boosting node. So each node has a set of results, some that are specific to the node, like the error plot and variable importance we get for our gradient boosting model, and some are common across nodes. On our assessment page of results that is produced for all the supervised learning nodes, you see various fit statistics, including lift and gain related plots across the partitions of our data. And we also have an ROC plot, representation of the confusion matrix, and much more. Now remember those variables we had tagged to assess for bias in the beginning, so we can detect if our model could be behaving unfairly across these groups. Let's look at that in detail. At the top are 2 parity plots that showed 2 different types of parity. We have performance bias on the left, which represents differences between various performance metrics across the groups, like misclassification rate, true positive rate. And then on the right, we have prediction bias parity, which looks at differences in average predictions for each group. Now, to help understand these plots and many of the other plots shown in the results, there is text provided here from our natural language generation or NLG service that creates descriptions based on the data used in the plot. So from here, we can see the 2 levels of our marital status, widow and civil marriage, had the largest difference in predictions between those 2 groups. We can look into that further in the plot below, where you can see the average prediction for each level to easily see how these predictions are differing across the various groups. Now, another part to responsible AI is understanding and being able to interpret your model and thus trust it. And that's not always straightforward with some of these closed box models like gradient boosting. So before running this node, I had turned on properties to request our model interpretability measures for this model so we can understand how our inputs are being used and affect the predictions, both across observations or looking at selected individuals. Since these measures were requested, we have this page with all of those results. So we can see up top in our PD or partial dependence plot how the 5 most important inputs for the gradient boosting model are affecting the predictions. And again, we can get some help on what this plot is telling us from our NLG service, including what this gray shading is telling us, and about the heat map representing the distribution of the inputs on the x-axis here. Then on the right, we have ice curves overlaid on the PD plot. These curves are for specific individuals in the data. And then the Lyme and Shapley values at the bottom are different approaches to showing how much each input contributes to the predicted value for specific individuals in the data. Now, these measures are helpful for any type of model, but there are, of course, models that are inherently interpretable, such as regression, where you can see from the parameter estimates how each effect contributes to the prediction, or with a decision tree, where you have a very clear visual of how your inputs lead to a prediction. You can even interactively open your decision tree to be able to insert your domain knowledge on how inputs are used to split your data into the leaves. But these interpretable models generally come at the cost of accuracy. There is an exception, though, with another model I want to mention briefly, a generalized additive model, or GAM, that I had included in this pipeline. This model is popular because it is both interpretable and often more accurate than something like a regression model. You can see in the results these plots of spline terms that give a clear picture of how the input is related to the predicted probability of repaying the loan. Now we'll move to the Pipeline Comparison tab that shows the champions from each of the pipelines and also automatically identifies the overall project champion. We can add any challenger models we want here, and you can see the various options for putting your model into production. You can register your model directly into Model Manager or publish to the destination of your choice. And finally, there's the Insights tab. This automatically gives you a summary of your project, and the text here is again from the NLG service indicating the champion model, important inputs, and you can add any notes you want to share, and there's various other reports. You can easily create a PDF with these various items as a major shortcut for sharing information and communicating with any stakeholders of this project. The results of any node can also be saved to a PDF report. Now we're going to turn our attention to visual forecasting. Model Studio for this domain is for generating forecasts from historical timestamp data. Similar to machine learning models, forecasting models can be assessed and compared in order for a champion model to be determined. So you'll see a lot of similarities with the machine learning project, including the Model Comparison node, Pipeline Comparison tab, and Insights tab. The time series data here is looking at the revenue of various skincare products over time with the goal of forecasting future revenue. Just like with machine learning, there's automation in this pipeline environment that allows for the generation of forecast models at scale with little manual intervention needed. So, for example, here's a pipeline from the auto forecasting template that performs automatic modeling to find the best model for generating forecasts from the various model families. A demand segmentation template automatically segments time series for you based on patterns like seasonality. Then each segment can be modeled separately in its own nested pipeline. And here's a pipeline that combines machine learning with forecasting to produce highly accurate forecasts. You can see there are several nodes using neural network models, including this panel series neural network node where you can auto-tune the neural network that's used. Other nodes combine time series and machine learning techniques as well. And finally, I want to point out this Overrides tab that's unique to visual forecasting. This again addresses responsible AI by helping you understand the forecasts being produced and not just have to blindly trust them, with the ability to insert your own domain knowledge to manually override any of the automatically generated forecasts. Now let's take a look at visual text analytics. Model Studio for this domain helps you identify and categorize textual data, build concept models, and determine sentiment in your documents. I don't have time to go into details on that, but I want to show off a very cool productivity enhancement that was released earlier this year. So let me go ahead and open this text analytics project with this data. I'll give this text variable the text role, And you can see here this option to automatically detect languages. So let me go ahead and run that. And while that runs, let's take a look at our data. And here in our text column, you can see there are many different languages being represented. And you can see these were all automatically detected for you. Now in your Pipelines tab in your data node, you can specify which language you want to subset the data to examine in this pipeline. And you can then easily reuse this pipeline for other languages. So this has been a quick overview of Model Studio and the tools that it provides for automation and responsible AI. But be sure to check out some other sessions. There'll be a focus on analytics at the Day 2 General session, talking about trustworthy and responsible AI, as well as machine learning driven intelligence. You can also see a super demo using Model Studio and other SAS Viya tools to visualize and build a predictive model for greener travel. Thank you very much for your time and attention.